So we started out with these really basic problems of coarticulation and lack of acoustic invariance. And these are the two things that motor theory is really inspired by. And then we'll look next class at how it also applies to some of the other problems we've been looking at. But for now, here's how they state the coarticulation problem. The movements for gestures implied by a single symbol, remember where the symbol here is something like an IPA transcription, so P, are typically not simultaneous, and the movements implied by successive symbols often overlap extensively. This coarticulation means that the changing shape of the vocal tract, and hence the resulting signal, is influenced by several gestures at the same time. That's basically their statement of what coarticulation is, which we've gone over several times. Thus, the relation between gesture and signal, though certainly systematic, is systematic in a way that's peculiar to speech. Right? So this is them essentially saying that our naive learning model, where you pluck acoustic features out of a string of acoustic sounds and then match them to features, is not going to work. Instead, we need to do that acoustic to gesture mapping in a way that's peculiar to speech. Applying the motor theory to our example, we suggest what has seemed obvious since the importance of the transitions was discovered. And this is talking about the formant transitions from a consonant to a following vowel, where we saw that just those transitions can make the difference as to whether you hear a b, d, or g. At the same time, there's no fixed acoustic values for where the formants have to start for a b, d, or g. It's just the shape of the transitions that matters, and that varies depending on the following vowel. Right? The listener uses the systematically varying transitions as information about the coarticulation of an invariant consonant gesture with various vowels, and so perceives this gesture. And here's where things start to get a little bit wild. Right? So what they're saying here is that the reason there's no acoustic invariance in, a duh transition into an a vowel and an e vowel and an oo vowel, where we saw this earlier in the last class, that you can't really pick anything out in the acoustic spectrogram and say, look, that's the coronal frequency. Instead, it seems to be just different shapes of transitions into different vowel formants. And what they're saying here is, well, that's because what you're getting out of the speech signal is not the formant values. What you're getting out of the speech signal is the gesture or the gestural goal. I'm trying to move my tongue tip to my alveolar ridge, or I'm trying to move my tongue body to my soft palate for a velar stop. All right? That's what you're trying to recover from the speech signal, is what was the intended phonetic goal of that sound. And their claim is that you're using the way that the actual sounds change in order to infer what the unchanging phonetic goal underlying those sounds must have been. Right? So this is going to be significantly more complicated than just scanning a spectrogram, getting some values out of it, and going, yep, excuse me, yep, those are the coronal values, or yep, those are the velar values. Instead, their claim is that you're using acoustic variance, right? The way that different acoustic values change to figure out what kind of an unchanging articulatory goal or command might have been going on. And that, according to them, makes this very different from other kinds of hearing, because in other kinds of hearing, presumably what you're trying to extract from the signal really is some kind of a sound property. But in speech in particular, what you're hearing is the intentions of the speaker, not the acoustic disturbances that they cause. Right? So that's kind of wild. We'll go into more detail about this next week. Things to notice here. We started off this class with our big picture, very vague overview of different schools of thought in the history of the natural sciences and cognitive science. And of course, the motor theory is going to fit in a very specific way into this picture. If you choose the motor theory for the next assignment for next week, you'll get to look at this yourself in detail, but let's talk about it a little bit here. Here's what they have to say. This is a very telling paragraph. This link, we argue, and they're talking here about the link between different kinds of acoustic sounds and the intended phonetic gestures that lay behind them, we argue is not a learned association, a result of the fact that what people hear when they listen to speech is what they do when they speak. Rather, the link is innately specified, requiring only epigenetic development to bring it into play. In other words, you are born with knowing the relationship between intended phonetic gestures and their acoustic consequences in some sense, or at least you're born with a strong propensity to learn only the correct mappings there, where all you need in order to bring those mappings into play is to be exposed to some language. On this claim, perception of the gestures occurs in a specialized mode, different in important ways from the auditory mode, where we're talking about hearing anything else that isn't speech, responsible also for the production of phonetic structures, and part of the larger specialization for language. So, yeah, strong statement here from the motor theory. And to foreshadow a little bit, in the rest of this unit, we'll see that at this point, 30 to 40 years later, very few people believe in the motor theory anymore. It's been largely abandoned, but it's super important because it happens early in the development of the subfield, and they take an incredibly strong position about what kind of a cognitive thing speech and language are. And that allows for falsifications and tests and developments of the theory. Even if it all turns out to be wrong, this is a very strong position they're staking out here. So here are some questions. Again, these will pop up on the homework. Would you say that this statement is more of a rationalist approach to speech perception or more of an empiricist approach? Would you say that this is more of a modular approach to language or more of a domain general kind of approach? These are some big ideas we talked about in that first unit. Hopefully you remember what these mean, and it really should be pretty obvious what the answers to these questions are if you've understood this paragraph in this lecture. Going into a little bit more detail in cognitive modules and modularity, this will be the last part of this week's lecture. Just wanted to outline some of the properties that are said to characterize modular cognitive areas or modular domains. This is a bunch of criteria that you often or maybe always find with modular activities, and a lot of these were formulated by the philosopher of mind Jerry Fodor in the 1970s. The crucial ones here that we'll be most focused on in this class are the third and the fourth, but I wanted to briefly go through each of these. When something is a kind of modular cognitive activity, it means that it's in some sense separated or different from other kinds of activities that might at first glance seem to be superficially similar. Modular activities, modular cognitive abilities tend to be incredibly fast, right? It takes you a fraction of a second to perceive an entire word or an entire sentence, right? It's almost instantaneous. It tends to be automatic and or effortless, right? So when you're perceiving my speech, not only do you not have to try real hard, but actually, if I'm talking and you don't have anything else blocking your hearing, it's extremely hard to not perceive my speech. In some sense, that's what automatic gets at. You don't really have a way of turning off your speech perception, right? If there are people talking within your hearing range, you're going to be processing their speech whether you want to or not, right? So that's what they're getting at here with automatic. modules are domain specific. So for instance, right, there's a claim here from the motor theory people that when something comes into your ears and it has some properties, they haven't said what yet, but whatever properties allow it to quote unquote count as speech, right, then that's going to go into your motor theory intended phonetic gesture module. And if other things come into your ear, this is what they talk about as the auditory domain, that are, I don't know, doors slamming or cars beeping or the wind blowing, they're going to not go into your motor theory module. They're going to be in the general auditory domain, right? So that's what domain specific means, is that the system, in this case motor theory, applies to some inputs but doesn't apply to other inputs. That's domain specificity. Now, usually we're focused on somewhat similar inputs. So the claim here is, not only does this apply to some inputs and not others, but it applies to certain auditory inputs and doesn't apply to others, even though they're also auditory. The fourth one is super important, usually in higher levels of grammar, though it also comes into play in speech perception. It's the idea that modules, cognitive modules, are informationally encapsulated. What does that mean? It means that the kinds of representations and information that are getting processed inside the module can only communicate in limited ways with other cognitive areas or cognitive domains, right? So a particular claim in speech perception might be that the early activities you're doing when you're first hearing a speech sound and identifying its phonetic features aren't influenced by, I don't know, emotion or something like that, or they aren't influenced by your world knowledge, or so on and so forth. And there's various experimental results that have tried to question that for speech perception. So that's certainly not uncontroversially true, but that's what it would mean for speech perception to be informationally encapsulated. The activity of this motor theory module for doing speech perception is not affected by things like what you had for breakfast, who else is in the room, what your emotional state is right now, or what you're expecting the person to say, given that you just spilled a jar of pickles on the floor. The claim is that speech perception operates on its own automatically in a modular fashion and isn't affected by those kinds of considerations. That may or may not be true, but that's the claim. And the last one here, localized in the brain. Right? And so this is, again, suggesting that because cognitive modules are by definition sort of distinct from other kinds of cognitive activities, presumably they should be located in certain places in the brain. Now, that said, after 150 years of neurological study, I don't believe that there's anybody in the world who can look at a brain and point out to you where the speech perception part is. And in fact, I'm not sure that you can do that for any cognitive faculty, but that is the ideal in cognitive neuroscience, at least, that if you have distinct cognitive systems, they ought to be located in specific different places in the brain. The different places we have lots of empirical research on in cognitive neuroscience, and you can definitely find all sorts of localization differences in the brain between different kinds of behavioral activities. The localized part is much, much trickier. And at a first pass, I would say it's probably naive and simplistic to think that any particular information processing function is going to be tightly tied to a particular location in the brain. I highly doubt that myself, and that's a hunch, but more systematically, I don't know of any evidence that that's true for any cognitive function. It doesn't look like most complex cognitive activities are actually localized anywhere in the brain. So having said that, that's still part of the ideal of what cognitive modules are like. And maybe we can weaken that neuro part to say that at least if two different modules are active in two different behaviors, there should be some differences in how they're located in the brain. Next week, we will look in more detail at how the motor theory accounts for the other kinds of mysteries we've been talking about, and how it compares to other approaches to speech perception. And I've asked you to adopt one of those theories for next week and answer a few questions about where it fits into this picture.